Today we will be learning about setup and calibration. The first step is to turn on the computer and cameras. You do this by flipping the switches. Same thing goes for the force plates. There are switches in the back, and then you want to press operate for each. Depending on the study, you might want to connect your reference video cameras. This is simply to capture, say, a dance routine or whatever your participants are performing. But it really depends on the study. You don't have to use them. But in case you do, you simply are going to open the Pylon IP configurator. This is found on the desktop of this computer. And then you're gonna right-click each Basler camera by clicking Assign Temporary IP Address. You're gonna type a number, 1 or 2, just to label the cameras, and then you're gonna click OK. The next step is to create a folder for our data collection, and we're simply gonna go to Files. You're gonna click on SSD data, also known as the F drive. You're gonna scroll down to the Jarvis folder. Make sure to double click on that. Then you're gonna click New Folder. Make sure to label your folder the day you're doing the data collection, just to know when you collected it. For the sake of this video, I'm just gonna label it practice and today's date. Now you can go ahead and open Cortex. There are different versions of Cortex, but in this lab you want to choose the latest or the newest version. Go ahead and close those tabs. When you open Cortex, the setup should automatically load, but if it doesn't, you're gonna go ahead and load the file. The next thing we want to do is check the sampling rates for motion and force data to make sure that they are correct. We're gonna do this by clicking the far left side. It should say analog. Then we're gonna go down and see that the motion is 250 Hertz. The shutter speed should be 1000, and this should be the default. We also want to check that the force is 1500 Hertz. This is also the multiple of frame rate is 6. Now we're going to set our working folder by clicking Quick Files. You're going to choose the folder we made at the beginning and click on Set as Working Folder. You'll know if you did it correctly if your folder shows up top. Make sure you are on Live Mode by clicking Live Mode. Now we're going to go down and click Connect to Cameras. There should be 12. If you connected the reference cameras, they will also show up. Go ahead and click OK. Click the play button. Now we're going to change the screen to 2D view, because we want to look and see if there are any reflectors appearing. We want every box that represents each camera to be 0, because 0, or if a number appears, represents the number of reflectors, but we want that to be 0. Examples of reflectors might include sports logos, watches, jewelry, sometimes water bottles. So make sure that the surrounding area near the cameras does not have anything that is reflective. As you can see on the screen, there is nothing reflective because all the boxes have zeros. But for the sake of this video, I'm just going to show you what to do if there is a reflector. Oftentimes, a reflector will appear as a dot on one of the squares, and you'll see a number indicating how many reflectors are appearing. As you can see, a 1 appeared. It's because I tossed a reflector on the floor. But to mask this, we are gonna click the middle of the mouse and make a little box around it, just so it doesn't appear or affect our data. And then it'll go back to 0. Let's go back to 3D view by going up top, click data view, and then scroll down, click 3D view. Right now, I am just demonstrating how to move the screen. You can do this by holding down the Alt key, clicking the left side of the mouse, and moving the screen around. If you want to zoom in and out, use your middle button on your mouse and scroll up and down. Last step before we calibrate, we are going to zero out our force plates. Go back to the left side and click on analog, go down to force plate forces. Zero out the force plates by pressing the 0 button. That concludes setup. Let's move on to calibration. Go down to the left corner and click Calibrate. We are going to start with initial calibration and then click Next. Before we do anything else, we need to build our L-frame, so don't click on anything on the screen. Let's go get the L-frame that is found in Lab 174 in this shared lab cabinet. The L-frame is made up of 2 pieces. It's pretty self-explanatory when putting it together, as you can see on the screen. Once you finish building it, you are going to place it on the force plates. Every lab is different, so the L-frame might look a little different in terms of the position depending on the lab. But basically what the L-frame is for, it sets the origin and the axes. Make sure to check that it is leveled. Now we're going to go back to the screen, click OK to overwrite, and then click Next. Before we move on, I forgot to mention that you're really looking to see how many reflectors are appearing in each camera. You're ideally looking for 4 in parentheses, but some cameras don't really work in this lab, but ideally all cameras should have a 4. Before we do the wand calibration, go ahead and remove the L-frame and go back to the box to build the wand. Please do be careful when building the wand because it is fragile and quite expensive. So just keep that in mind. We are ready to move to wand calibration. Click OK to overwrite and then click Next. For this part, you really want to have two people. You want one person monitoring the computer while the other person will be moving the wand through the space as appropriate for the volume you will be using for data collection. So a tip you want to do is spend more time moving the wand in the area you are going to use your collection. There are many techniques. I will list some in the next slide. Once the wand calibration has been finished, you're going to get 3 columns appear on your screen. We're really going to focus on the second and third. The second one indicates how much area was covered. The third one indicates how much was left out. We want to focus now on the third column and see that our numbers should be less than 3,000. But if it's more, like in this case, we would ideally click previous, but for the sake of this video, I'm just gonna click next. After the computer does the calculations, we're gonna take a look at our results. We're gonna look first at the first row and see that, take a look to see if everything is below 0.23. Then you're gonna look down and see if the average is less or around 1, and you also want the standard deviation to be half of that. Take a look that the wand length is 500 and we should be good to go. If it's not, you would click previous and redo the wand calibration. Again, for the sake of this video, we're just gonna click finish. Go ahead and click OK. And just to check everything, we're gonna go up to data views, 3D view, and then you're just gonna have someone walk around with the wand just to see if the cameras are working. Go ahead and press stop. Now we're going to save our file by going up to File, go down to Save Setup. The final step is to save it in the folder you had initially created. So look for the folder, click on the folder, and then you're going to name it. For the sake of this video, I'm just going to name it Practice and today's date. And when you're done, you click save, and that is it. And that's pretty much it for setup and calibration. After you save your file, you can go ahead and exit out of Cortex. I hope this tutorial was helpful, and good luck on your projects.